All right, so last time we said that valence electrons are very reactive. So naturally, the next question is why are valence electrons reactive? And that has to do with the idea of shielding. Shielding. So let's take a look at an example. We'll take a look at lithium. For example, lithium has 3 electrons, and its electron configuration is the 1s2, 2s1, right? 3 electrons there. And to really understand this, the best model to look at is to look at the Bohr model. So remember, in the Bohr model, we've got our nucleus. This time I'm going to explicitly draw 3 protons, and I won't draw any of the neutrons. The neutrons are still there, I just didn't draw them. And then around it, we have orbits, right? So this is an n equals 1 orbit, and then this is an n equals 2 orbit. And since we are 1s2, we have 2 electrons in our n equals 1 orbit. And then we have 1 electron in our 2s, or our n equals 2 orbit. And so let's think about what's going on here. Remember that in our center we have positively charged nuclei and electrons are negatively charged. And remember, opposites attract. So a positive and negative charge are going to attract. So if we take a look at these 2 electrons, you can see that they're right next to the nucleus. And so they're getting pulled by the entire nucleus. So these 2 electrons feel an attraction of 3 plus. Let's take a look at this one right here in the 2s orbital, right? Still attracted by that nucleus, so we can say attracted by a 3 plus charge. But then before it can get, or before in between it and the nucleus are now 2 electrons. And remember, electrons are both negative, so opposite or same charges repel. So this is being attracted by the 3 plus in the nucleus, and at the same time, it's being repelled by 2 electrons, the 2 electrons in the n equals 1 shell. So it's repelled by a 2 minus. And so if you kind of net this, the outer electron only feels a pull of 1 plus, right? Because it's negated by the 2 electrons. And so this is what we mean by shielding. These inner electrons, they feel the full effect of the nucleus. These outer electrons do not feel the full effect of the nucleus because they're being shielded by inner electrons. And so if you're thinking about lithium generally wants to go to +1, so one of these electrons is going to get ripped away. Well, which one are you going to get rip away? Are you going to rip away the one that's being pulled by 3 plus or the one that's being pulled by 1 plus? And the answer is the one that's being pulled by 1 plus, right? So this is much easier to pull away. While this one over here feels the full 3 plus, and so this is hard to pull away. And so that's what shielding is all about. And that's why valence electrons are more reactive. So the end rule is that inner electrons shield, you can say inner / core electrons shield outer electrons from the pull of the nucleus. And all that matters is the n here. The L doesn't matter, right? So if they're the same n, they don't shield each other. So, core electrons shield valence electrons, and that's it.